In the previous videos, we learned how to use the order of operations to simplify these expressions. And we call these expressions numerical expressions. The word numerical comes from the word number, because you can see in both expressions, we only see numbers. We don't have any variables. And of course, we have the operation symbols. But there are some expressions, they have variables in there. This one is also numeric expression because we only have numbers in here. Again, number, numerical. But in these two examples, we can see this expression has x, y, z in there, and this expression has a and b in there. And so we call these algebraic expressions because it started to involve algebra. And so how do we simplify these? And usually they will tell us a number for each variable. For example, here x is 2, y is 5, and z is 1. And in the second example, a is 3 and b is 2. So the first thing we do is to plug those numbers in the algebraic expression. For example, we replace this x with 2. We replace both x's, this x and this x. So in the same expression, and the one letter x, the variable x, they're the same thing. So same x, and then we have same y, 2 y's and 2 z's. Okay, so after we plug everything in there, and we're going to get this numeric expression. So an algebraic expression with variables in there, x, y, z's in there, can be turned into a numeric expression if we know the values for each variable. So here you can see x, both x's are replaced with 2, and the y's, and these 2 y's are replaced with 5. Y is 5 here, and this y is also 5 there. And finally, the variable z is replaced by 1. And everything else, we have to keep them. For example, there's a number in front of x, so we have to bring it down. There's a -5 in front of x, we bring it down, and +3, we bring them down. And also, we need to remember, so because in the algebraic expression, for example, 8xy, the operation between them is omitted. Between 8 and x, there's nothing. And remember, that is multiplication. So you can go back to watch our first video. And between x and y, there's nothing. It also means multiplication. But after we plug in numbers, we cannot leave them as they are. We have to put the dot back. So because if we don't put the dots, it turns this into 825. So with the variables, the letters, there's no confusion. So we can omit the multiplication symbol. But once we plug in numbers, we cannot omit the multiplication symbol. We have to put them back, either use the dots or parentheses. Because usually dots is easier to write than, pale parentheses. So we prefer to use the dots. Same thing for 5xz. So put those dots back between them, and 3yz, put those dots back. So after we plug in numbers, now we're going to follow the order of operations. We know multiplication. We have a bunch of multiplications, and we have a subtraction here, addition here, and we know a multiplication has higher priority than subtraction and addition. So let's work out all the multiplications. We can now go a little faster. 8 times 2 times 5. Now later we will talk about properties of some certain operations. For example, if we have 2 multiplications here, 8 times 2 times 5, we can multiply any 2 numbers we want. There's a property called commutative property and associative property. and which will be discussed later. So if you know those properties, you can go ahead and use them. For example, you can multiply 2 and 5, which gives you 10, and then multiply 10 with 8, which gives us 80, which is easier than following the left to right order. 8 times 2, 16. 16 times 5 is 80. Both are correct, but using the properties can simplify the process. So this first two multiplications give us 80, and 5 times 2 times 1, that's a 10, and 3 times 5 times 1, that's a 15. And remember, any number times 1 would be itself. So when we do 5 times 2, it's 10. 10 times 1 would still be 10. 3 times 5 is 15, and 15 times 1 will still be 15. So after we multiply all these numbers out, we got 80 minus 10 plus 15. Now let's follow left to right order, because subtraction and addition, they have the same priority. So we do 80 minus 10, that's 70. 70 plus 15, that gives us 85. Now let's look at the next example. So the first step, we're going to turn the numeric expression to, turn the algebraic expression to a numeric expression, which means you will get rid of all the variables and replace them with numbers. By the way, here is the explanation for the property that we talked about right here, 8 times 2 times 5. So instead of doing 8 times 2, 16 times 5, we could multiply 2 times 5 to get 10 first, and then multiply 8 and 10. So that's called associative property. Okay, so now let's look at example 8. We are going to first plug in numbers. So this A, these two A's, we got to replace them, both of them, with the number 3. So substitute 3 for A's, and substitute 2 for those B's. But everything else, we have to keep them. And also remember, between 4 and A, there's nothing, and it has to be multiplication. Between 3 and B, it's multiplication. Between 5 and A, that's multiplication. So after we plug in numbers, make sure we put those multiplication symbols back. And now we can follow the order of operations. So remember, first we're going to work parentheses. Okay, parentheses always have the highest priority. So we're going to start with each pair of parentheses, because we have 2 pairs. Now, first pair, inside the first pair of parentheses, we also have 2 types of operations: multiplication and addition. So we have 2 multiplications here and 1 addition there. And we know multiplications have higher priority. So we're going to work out both multiplications. 4 times 3, 12. 3 times 2, 6. So we have 12 plus 6. And if you can do that in your head, 12 plus 6 is 18. You can go ahead and do that. Or you can slow down. And same thing here, I'm going to work this multiplication out in the second pair of parentheses, which gives me 15 minus 2. So I slow down. I did the multiplication, 12 plus 6, and I did 5 times 3, which gives me 15. And now I am going to do the addition and subtraction in each pair of parentheses, which gives me 18 times 13. Now to do 18 times 13, you may have to use the standard algorithm. You're going to set up as 18 times 13. And when we do multiplication, we multiply 3 and 8 to get 24. But that little 2, you can keep it somewhere, like either down here or up there. And then you're going to do 3 times 1. So we do 3 times 8, 24. Put 4 down, because 4 is in the ones place, but 2 is in the tens place. So we're going to put it up above 1. And then 3 times 1 is 3. 3 plus 2 gives us this 5. All right, so next we're going to, when we finish multiplying 3 and 8, 3 times 18, now we're going to multiply this 1 and 18. But remember, this 1 doesn't really mean 1. This 1 actually means 10, because it's in the tens place. So you're doing 10 times 18. So the first thing we need to do is write down a 0. Put a 0 down, because we're doing 10 times 18. So we're going to get literally 18 times, which is 180. But we can slow down and put down a 0 to represent the 10. And then we do 1 times 8 is 8. And then 1 times 1 is 1. So we got 180. And after we finish both multiplications, which is, so literally we have to do 2 steps, 3 times 18, 54. And then this 1 means 10. 10 times 18 is 180. Now we can add them. 4 plus 0 is 4. 5 plus 8 is 13. And when we write down 13, we actually only write down 3, and we put a little 1 to line up with the other 1, and then 1 plus 1 is 2. So that gives us 234.